get started with the last talk of the session. The title of the talk is EPMC Gets Knowledge in Multi-Agent Systems, and the talk will be given by Chen.
Thank you for the introduction. My name is Chen, and I'm presenting our paper, EPMC Gets Knowledge in Multi-Agent Systems. Well, the first question is, what is EPMC? Well, EPMC is an extendable probabilistic model checker. It provides model checking functionality for probabilistic systems, such as discrete time Markov chains, Markov decision processes, continuous time Markov chains, stochastic multiplayer games, and probabilistic parity games. And it supports PCTL, PLTL, and PCTL star. It is mostly developed in Java and also uses GNA library to access C and C++ libraries. And it is built by Maven. The advantages of EPMC are its high modularity and full extendibility. It consists of a minimal core and multiple plugins. To demonstrate such features, we have developed EPMC-petl on EPMC, which is a model checker for probabilistic multi-agent systems against probabilistic epistemic temporal logic. Okay, let's start with the architecture of EPMC. The core of EPMC is rather small. It is only responsible for the bootstrap phase. In this phase, the core first loads the plugins, and then initialize the data structures, and then call the plugins to parse the input models and properties or other input files, and then call the plugins to start model checking. The core has no information about plugins, so each plugin should register itself in EPMC as follows. First step, a plugin should declare its name and that it is an EPMC plugin in its manifest file, and then list the plugins it depends on, and then implement all interfaces defined by the plugin manager. And here I give an example of the manifest file. We can see the first line shows that it is an EPMC plugin, and the second line shows the name of this plugin, and the last line lists the dependencies. And after the developer has registered a plugin in EPMC, then the developer can just implement the functionality he wants. And after that, if one wants to use a plugin, he should insert the plugin to EPMC. There are two ways to do this. The first one is just place the plugin in the embedded plugins folder and list its name in the embedded plugin file. Or one can also just insert the plugin by in command line. EPMC provides such options to do that. And So what we can do in a plugin? We can add new commands, new command line options, add new commands, new data types, new models, logics, parsers, and also new algorithms. But just note that a plugin loaded later has a higher priority than a plugin loaded earlier. That is to say, if two plugins modify the same option value, then the value of that option will be given by the plugin loaded later. For now, EPMC has provided about 50 plugins. Here I give a brief overview of such of these plugins by group. In each group, there are one or more plugins. So I just briefly introduce their functions or purpose. The algorithm group contains the plugins which provide classical algorithms, such as the graph algorithms, for example, the algorithms to compute maximal end components of strongly connected components. And the automata group contains the plugins which can encode omega regular automata. And the plugins in the command group provide main functions, such as performing model checking operations, printing help informations, or export a model which is similar to the input model. And the BDD group contains the plugins which support symbolic representation. The DD plugin provides all the interfaces, and now EPMC has supported many BDD libraries such as body, CA, CBDD, CUDD, and so on. And the bisimulation group contains the plugins which provide computing bisimulation relations for probabilistic systems. And the plugins in expression group provide the interfaces to handle formulas from temporal logics. And the plugins in graph group provide the interfaces to store graph, and the plugins in graph solver provide algorithms solving linear programming problems. It both supports Jacobi and Gauss-Seidel iteration methods. And the plugin in Jenny format group provides a function to parse or export models and properties in Jenny format. Similarly, the plugins in PRISM format group provides operations in PRISM format. And the plugins in property solver group provides algorithms solving properties during model checking. And similarly to the BDD group, there is one plugin, property solver, which provides other interfaces, and all other property solver plugins should implement such interfaces. And other plugins in this group provide concrete algorithms to analyze some class of different class of properties, and the util group contains plugins which support basic utilities, and the value group contains plugins which provides interfaces to represent all kinds of values and types. And this figure shows the dependencies between the previous group of plugins, and an arrow in this figure, an arrow from a group to another, means that the former one requires the later one. And if one developer wants to add a new plugin in EPMC, then he should pay attention to such dependencies. And in order to demonstrate the advantages of EPMC, we have developed a model checker on EPMC, which supports PCTL model checking. So let's briefly introduce the problem. And the model here is probabilistic multi-agent systems. In such systems, there are non-deterministic behaviors and probabilistic behaviors. And the agents usually have incomplete information. Each agent makes its decision based only on its limited information. And the incompleteness is modeled by equivalence relations over states. That is to say, if two states are considered equivalent for a given agent, then the agent should choose the same action on these two states. So in the model checking problem, only a part of scatterers should be considered, which is different from the standard PCTL model checking, where all scatterers are considered. Then the problem can be solved by linear programming problems. And so in order to develop such model checker in EPMC, we first need to pass the input files. Regarding to the model, we use MDP, so we can just reuse the parser from models in the PRISM format plugins, which has supported by EPMC. And the property here is expressed in PTL logic, where compared to PCTL, standard PCTL, there are 4 new epistemic operators. So we need to extend the parser for properties in the plugin PRISM format. And besides, there is also a file including equivalence relations, which consists of blocks. For each agent, there is 1 block, and each block contains a set of formulas. And if 2 states satisfy the same formula, then they are regarded to be equivalent. So the formulas in 1 block should be pairwise disjoint. And for these equivalence relations, we need to develop a new parser. And after we have get the input models, properties, and relations, we need to consider the solvers. The PCTL, the PTL property is checked bottom up, with each operator managed by its corresponding solver. There we can reuse some solvers in EPMC. For example, the solvers dealing with the propositional formulas and the operators like negation, conjunction, disjunction, and next. Because in the semantics of PTL, we only consider part or scalars, so we need new solvers for the until operator. We have implemented two solvers for this operator. One is one reduced the problem to mix integer nonlinear programming problems. And the other one is based on UCT algorithm, which is an approximate algorithm. And for new epistemic operators, we need developer. Also need to develop a new solver. And this picture, this figure shows the architecture of PTL model checker, and as we can see, is largely shared with EPMC model checker. From the command line, we get the model file, equivalence relations file, properties, and options. And for some parsers, we can reuse the ones in EPMC, and we also need extend and develop some new parsers ourselves. And for the solvers, we can also some solvers in EPMC. And in conclusion, EPMC is an extendable probabilistic model checker, and it supports probabilistic models and PCTL star. And the advantages are high degree of modularity and full extendibility, and it consists of a small core and multiple plugins. To demonstrate the advantages of EPMC, we have developed EPMC-PCTL, a model checker for PTL model checking, which exploits the minimal core and multiple plugins. And the development of new functionalities is independent from the existing ones. And this speeds up the implementation and simplifies the debugging. And finally, EPMC, including EPMC-PTL, is open source, and you can find the source code on GitHub by this link. And this is the end of my presentation. Thank you. Any questions?
Questions? All right. So how long did it take you to implement this EPMC-PTL? How long did the implementation take using the EPMC? Can you hear me?
Yeah. I can hear you. You mean the time to develop EPMC-PTL?
Right, right. Because I mean, the point is like this whole framework speeds up the implementation process, right? So, in terms of
Yeah,
manual work, how long did it take the whole implementation
yeah,
process?
I see. If the developer are familiar with the core and some basic plugins or EPMC, I think this step don't take doesn't take much time, and then developing a new plugin like EPMC-petl, I think several weeks will be enough.
All right. Could you comment a little bit on the limitations of this framework in terms of, you know, what kind of extensions are easier to do versus what are harder to do?
The limitations we are working on, one limitation we are working on is the time efficiency, because in order to keep the modularity and the extendibility, the time we are still not satisfied with the time efficiency. Yeah, that is for some operations I think it is slow, and we are working on that.
Any other questions? Are there any questions? Yeah, there are no further questions. Then let's thank the speaker again. And
Thank you.